of 0-1 knapsack, and we have seen what is memoization. We were successful in converting the recursive approach of 0-1 knapsack into a memoized version. So we did a memoization, and in memoization, what we did was we just took a table of almost the same size, this number of items plus one into number of call the capacity plus one. So in this two-dimensional matrix, whenever I used to have a recursive call, I computed and I stored it in a table. So next time when I had a requirement of once again computing value for that function routine or subroutine there, instead of calling and traversing entire recursion tree down that call, I used to just take a value from this table and go further in that algorithm. So that saves a lot of time, and we did see that approach in last lecture. So what we will do is we will slightly approach this problem with a different method, and this method is called as bottom up. Whatever method we saw till now, the recursive approach is called as top down, and this is called as bottom up. So I'll not explain you why it is bottom up, why it is top down, what is that, because of which we call them top down, bottom up. We will all that questions and all that understanding we will say it after once we're done with this session, right? So as of now, we'll just look at this method of this, right? So now I hope you all know why it is 0, 0, and 0. Let me quickly explain you what this value stands for. So see, these are the index of this 2D matrix, so 2D array. Now here these indexes have a specific meaning. When I take a columns here, these denote the capacity, and these denote the size of subproblem, right? And when I say 0, 1, 2, 3, I always start from I1, I2, I4, and so on. We start from I1 and we end till I4, or maybe IN in a general case. So when I say 0, what this cell represents? This cell represents the maximum profit I'll have if the number of items in my subproblem is 0 and the SAC capacity is 0. So profit is 0. Likewise, when number of items in my problem are 1 and SAC capacity is 0, what's the max profit? 0. So likewise, all this entire column will be 0, 0. If the SAC capacity is 0, no matter how many items we have, the profit would be 0. And if I have 0 items to process, no matter what the size of capacity, no matter what the size of knapsack, the profit I can earn is always 0 and 0, right? Okay. So now what we will do is, if you look at this equation, okay, look at this equation. What I have done, if I want a maximum profit, what I do, I want a maximum profit for items from I1 to I4 with M. What is M? M is the maximum SAC capacity. M is equal to 7. Okay. If this is the case, what I do, there could be two choices. Either I might get a profit by including this item or excluding that item. So I might get profit both the times. So if I include that, remember, if I include I1 in my solution, then I will be incurring the profit or the price associated with item 1. Plus, once I include this item 1, the SAC capacity will no longer be M. It would be M minus W1. Then what you have to do, what will be the profit? The profit earned by including item 1 and reduce the SAC capacity. Since you have included item 1, the SAC capacity gets reduced by W1, and you have to further solve what is the maximum profit you can achieve for items 2 to 4 with the given capacity. If you include this, if you include the first item, if you do not include, you have to just solve what would be the maximum profit for I2 to 4 and the knapsack capacity is M. And we saw this equation very frequently in recursive approach. And in recursive approach, what happening is this was expanding. So this had one subtree, and this had one subtree. For example, this was my left subtree in my recursion, and this was my right subtree. And for each you have two subtrees: include, exclude, so on. You had an entire recursion tree. So there you used to solve with a larger problem, then subproblem, and when you are coming back from recursion to main call, you are just taking the max of them. That was the recursive approach. Now, what we will do is, here instead of starting with a full sub problem, we start with the smallest possible sub problem. What is smallest possible sub problem? Only one item, right? We will assume that we are starting with only one item. Then we will find what is the maximum profit if I include that and if I exclude that. Then what I'll do is, I'll increase the sub problem size by taking two elements. Now, when I take two elements, I have already solved it for I1. So, while solving for I2, if I want the solution of I1, then I have already computed them. I am computing them and I am storing in this row, right? So, when I am solving for subproblem size 2, if I need anything related to subproblem size 1, I have already pre-computed them here. Likewise, when I'm doing for this subproblem with size 3, I have already computed values for this. That's how the table grows. So when I do it for 4, that I would already be having the values computed for size 1, 2, and 3. That's how the approach begins. So let us solve this for this on this table, and then we will convert this into an actual Python program. Fine. So here at this location, what does this indicate? What does this indicate, this row? This indicates if when I have one item to process, one item in the sense I1, when I have one item to process and SAC capacity is 1, what will be the maximum profit? What will be the maximum profit? Can you put that in chat window? We have already solved this. Just put that in a chat window. Yeah, the answer is 1. Okay. So now if answer is the 1, right? Okay. So SAC capacity, sub-problem size is 1 and maximum SAC capacity is 2. Can I include that? Yes, include, and maximum profit I can incur is 1. So this will be 1, this will be 1, this will be 1, 1, 1, and 1. Fine. Okay. So now what I have, sub-problem of size 2, SAC capacity is 1. If I have sub-problem of size 2, SAC capacity is 1. What is the maximum profit I can achieve? So here, remember, let me explain you. So what I am trying to do is, if I write this, see, remember what sub-problem I have right now? I'll put this in equation, then you will understand it better. So if I take this equation, what I have now, I1 to I2, that's what I have. I1 to I2. What is SAC capacity here? As of now, I have SAC capacity is 1. So I have to solve for this problem, right? So this would split into, how it will split into? So if I include this item, can I include this item? When would you include this item in the SAC 1? If the weight associated with this, if this weight can be permitted in the SAC capacity, no, I cannot include, because SAC capacity is 1, the weight of this object is 2, so I cannot include. So this entire will vanish off. I cannot include this, right? This is there is no possibility of this. So obviously what I would have here, so what I will have here is, okay. So this is, we are ruling out. I cannot include this. Okay, let me also write this in the order what you are doing that. From 2 to 2, from 2 to 2, and so the only option I have is the next remaining max box. Okay, so what is that? From I 2 to 2 and M. What is M currently now? 1. Okay. So what you're including is from I1 to 2. If you include, now see, now when you're including that, what you can do is you can include this item. Okay. See, here you have written from I1 to I2. The same thing I can write it in this way. For example, I can write it in this form. For example, P2 plus 1 1. Can I do this? P2 plus 1 1 from I 1 1 M minus W2 or max of 1 1 with 1. So whatever the above equation which I took, can I write it in this way? Okay, can I write it in this way? So now I have 1, 2. I'm started processing in reverse order here. So whatever the above equation which I took from I 0 to 1, 1 to n and all that, I can always write it in this form. I1 to 2, Y1 to 2 and 1. So if I want to take a decision for the second item, the profit which you get by including the second item plus the maximum by removing this weight, what was the maximum profit possible if you remove this from this one? For example, if you exclude the weight of this, right? Or if you decide to exclude this second item, you cannot include that. Then the only thing remains is max 1 to 1 with this one. So here, if you check here, this is completely ruling out because I cannot include this because the weight of this is 2 and the current weight under consideration is 1. You cannot include that. So the only possibility remains is from 1 to 1 to this. So what is the maximum profit I earn if the sack capacity is 1 and I have one item to process? What is that? One item to process, maximum sack capacity. What is that value? 1. So what I get here? 1. Are you getting? Are you getting for this? Okay. So now the tricky case starts from here. Okay. So when I solve for this location, let me highlight that so you will understand clearly for what location we are solving. So now I am solving for this location. If I include it for this location, what is that? Items are still 1 to 2, and what is the maximum sack capacity here? 2, right? This is my maximum sack capacity 2. So if I include that, two solutions. By including this item, what is the profit I get? If I exclude this item, what is the profit I get? If I include this element, what will be the profit? The P2, the profit associated with P2 plus the max of profit which I get for the subproblem newly created. If I include this, then I will be reducing this weight. So there should be something. Then I need to see what is something which I can achieve with reduced sack capacity. If I exclude this, the only option I have is this. So if I further convert this for this solution, can I include weight to capacity 2? Yes, I can include that. So now if you solve this, you get the following equation here. Okay, so what is P2 here? Profit for sack 2, P2 is 6. P2 is 6, max of 1 to 1, I1. What is M minus W2? What is weight associated with this? Weight is 2. What is maximum M here? 2. So M minus 2, what is M minus 2 here? M minus 2 is 0, right? Or max of this from 2. Now, if I further substitute the values for this, so 6. What I'm asking is, what is the maximum profit? What is the maximum profit when I have one item to process, which is I1, and sack capacity is 0? So what cell you look for? I11 means what you are looking for? One item to process. What is sack capacity? 0. What is sack capacity? 0. So you will take this value. What is this value? 0. So this is 0. 6 plus 0. And what is maximum profit I would get if I have one item which is I1 to process and sack capacity is 2. One item to process, sack capacity is 2. What is the here I have 1. So if I have 1 here, okay, what is max of this? What is max of this? 6. So what value you will write here? 6. Getting? Okay, so let me see if you have any questions. Are you did you understand why I have written there 6? You can respond here in chat window. Before I move further, I want to make sure you understood this. Have you understood why I have received 6 here? Okay, so yes, I have answer from yes. He said yes. Okay, so I'll move further. So I have a 6 here, right? I hope you understood this. Okay, so now if I go for next cell, so from this cell, I'll move to this cell. I'm calculating for this cell. So if I calculate for this cell, what will be the solution? Same, item is equal to 2. Now the sack capacity from 2 it becomes 3. If it becomes 3, what you will solve for? Same, profit is 6. M minus W2 is this. Max of this is same. So here M minus W2. What is M minus W2 here? M minus W2. W2 is 2. 3 minus 2. So here it would be, okay, and max of 1 to 1 to 2. So now let me solve it for this one. So you already have 6, right? 6 plus the profit of this is 6 plus max 1 to 1. What is this? The maximum profit I have when I have one item to solve. When I say one item, I always refer to I1. One item to solve with sack capacity as 1. One item to solve and sack capacity as 1. What is that? What you will get here? What value I get here? 1. So what is max of this? Max of 6 plus 1 and 1. And here it would be not 2, it would be 3 since it is. So max of this. So maximum profit I get when I want to process one element, which is I1, and when sack capacity is 3. One element, sack capacity is 3. What is that? 1. So 7 plus 6 plus 1 and 1. What is the max? 7. So what value you will have here? 7. Fine. So now I want to solve for this location. Okay. Can you tell me what value I'll get here for this location? The current highlighted red location. Will there be any change from 7 or I just keep on getting 7? Yeah, it would be 7 because I think only items to process are 2. So even if I increase the weight, it doesn't, I don't think any calculation will affect. So for 4, for 5, for 6, for 7, since all these values are 1, 1, 1, even if you do the calculation, you always get this 7. I hope you're getting this solution. Why I'm writing this 7. So you can do a calculation here. You will always get it as 7, 7 because I have only 2 items to process. So 2 plus 1 is 3. So if you have solved for 3 for all some capacities greater than that, you will get almost the same value. Okay, unless if there is any change in this. So all will be 7, 7 and 7. Okay. So now, so here the tricky part starts from here. Okay, can you tell me what you will have? So from now it is I 1 to 3. It is all 1, 2, 3. Let me increase the font if it is not visible. Okay. So for what we are solving for, let me just make everything 1, 2, 3, 1, 2, 3. You will understand. Okay. So let us solve for this one. Okay. What value you will get? Items to process are 3, which means that it would be I1, I2, I3 and sack capacity. So item to process are 3, and what I have, sack capacity is 1. So what is the sack capacity is 1? Yes. So if this is the case, then what you will get here, if you include this third element, profit would be 3. And what you will solve for, if you included this, so you will solve it for 1 to 2. Third, you are solving for third element, so it will be 1 to 2, 1 to 2, and 1 to 2. This would be also 1 to 2 with capacity. So here it would be dot W2, but it would be W3. Okay. So likewise, so what is profit P3? What is the profit associated with 3 here? 10. So 10 plus max of 1, 2. I'm just modifying the subscripts. Later on, we'll move it to the actual values. Okay, so for time being, let me remove these values. So I'll get two values. Okay, so what is P3? 10. And let me tell you, I am solving for this cell. Okay, so max of 1, 2, 3. What I have here? 10. So 10 plus max of 1, 2, 3. So what is M? Here, M is 1. M minus W3. What is M minus W3? 3. But if you take care here, the weight is 1. Weight is 1 and the weight of third item is 3. Can you include it? You cannot include it at all. So basically this you cannot include it at all. So if you cannot include it, what is the only possibility remaining? The only possibility remaining is this. So what it is? Maximum profit when I want to solve for two items, 1 and 2, for two items mean I1, I2 with weight capacity is 1. Obviously we are ruling out because the weight is 3 and the weight of this is 3. I cannot include in a sack of limit of size 1. I cannot include a item of weight 3 in a sack of capacity 1. So you are ruling this out. This will not be a there. You cannot have this here right now. So what's the only thing remaining? This. So two problems to solve. Two problems to solve. Wait, sack capacity 1. Sack capacity 1. What is sack capacity? 1. So if it is 1, what is the maximum value? This you cannot include anything. It's almost nothing here. So you have 1. What the answer here? 1. So what you will have? 1. Okay. So what will be the maximum profit for 2? Let me see if you can get a value for this cell. Okay. What you will have here for this cell? This the highlighted cell. So if I want to do highlighted cell, what is the sack capacity? It becomes 2. And can you still include? You cannot include because this is 3, 2. You cannot include. So this is not at all a possibility. So it would be 2, 2. Okay, so if it is 2, maximum profit I'll get if I have two items in a sack and I have sack capacity is 2. So two items, sack capacity 2. What is that? 6. So what value I'll have here? 6. Are you getting? Yes. So now if I solve it for next location, So now I want to solve it for this location. So if this location means the sac capacity is changed, it is 3. Okay, so if now tell me weight is 3, sac capacity is 3. Can I include this? Now, yes, now I can include this because this item is 3 and sac capacity is 3. So there is a possibility of including this. If there is a possibility of including this, then I'll include this one, right? 10 plus. So what this will become? Max of I122 M minus W3. So what is this? If it is M minus W3, what is M? 3. What is M? M is 3. W3 is 3. So minus, after taking minus, it becomes 0. So I need to take max of 10 plus what I have? Max of 1, 2. Max profit when I have two items to process and sac capacity is 0. Two items to process, sac capacity is 0. What it is? 0, or this max of 1, 2 and 3. So two items to process, sac capacity is 0. Two items to process, sac capacity is 3. What is sac capacity is 3? What is the answer you have? 7. So what's the maximum I'll get here? 10. Okay. So what value I have here? I think my mouse is not functioning properly. Okay. It is 10. Okay. So now we'll solve it for next. Tell me what will be the solution for this. Do you want to solve? Then you can just continue further. What will be solution for this? See, we will continue. I think it's almost 10:23. Let us complete this. You will understand this. So what is sac capacity now? 4. So what it would be P3. This would be exactly same. So now max of 1 to 2. Now you will subtract that. 4 minus weight of this third element. Now I have 1, right? So if you go through this, what it is 10 plus max of this call. What this call indicates? Two items to process, sac capacity is 1. Two items to process, sac capacity is 1. What is this? 1. So 10 plus 1, and this still remains. And if you exclude this, this is what you have. Maximum profit you get when sac capacity is 4. So what is this? What is this value? Max 1 to 2, two items to process, sac capacity is 4. What's the max of this? 7. So what is max of this? 11. Okay. So now I solve it for this location. Okay, 5. It is now 5. Can you tell me what's the profit? Okay, so I hope you should get the call what I am doing. From I1 to 3, max is this. So this still remains. Let me make all 5s first, then you'll understand. So M minus W3, 5 minus weight of this third item. 5 minus 3 is 2. So I should write here 2. So 10 remains same. So this is what I'm going to look. So I'll be looking for this. This I have already computed in the table. So from 1 to 2, two items to process, sac capacity 2. Two items to process, sac capacity is 2. What's the maximum value here? 6. So 10 plus 6, or max of 1 to 2 and 5 capacity, it is 7. So next all subsequent calls are 7 and 7. So what is the solution here? What the maximum profit you'll get here? 16. Okay, so you can already say, so 3 items to process. Remember, these are the 3 items to process. Weight is 5. So the most maximum is this 2, sum of this 2. It is 16. Okay, tell me what value you will have it for this. Can you calculate and tell me? For the current highlighted one. Okay, it is 6. So m minus 2 will be 3. And this will be 6, 6. So max of 1 to 2, 10 plus maximum when I have two elements to process and stack capacity is 3. Two elements to process, stack capacity is 3. What is the element I'm getting? 7. So 10 plus 7, or max of 1 to 2, 6 is 7. So what is the maximum value I get here? 10 plus 7, 17. So this value will now become 17. Now I will solve it for next location. We'll complete this. So, okay, at least okay. Tell me what you'll have. What is the maximum stack capacity? 7. 1 to 7. So m minus w3 means m minus w3. What is m minus w3? 5, 7 minus 3, 4. This remains 7. So if this is a case, what is maximum? 2 items to process, 4. 2 items to process, 4. It remains 7. And what is I want to 2? 2 items to process, 7. Still it is same. So what you'll get is 17. Okay, clear? Is it clear? Okay. So now let us do it for this location. So here is where you start getting a solution for entire problem. Now what I'm processing for I1 to 4, and sack capacity changes. Sack capacity is 1. So let me just make it is from I1 to 4, then it becomes I1 to 3. I1 to 3. Let me just change it from I1 to 3. I1 to 3. Here I have I1 to 3. I1 to 3. 1 to 4. I1 to 4. Okay, now it is clear. So let me first solve it for this line. Max of I1 to 3. So I1 to 3 is sack. So what you're taking 3 items to solve. What you're asking here? 3 items to solve, sack capacity is 1. 3 items to solve, sack capacity is 1. So what's the answer? 3 items to solve, this is P3. Can you include P3 with weight 5? Obviously, then this entire thing will be ruled out. This will be ruled out here, right? All this will be ruled out here. So this will be ruled out. You cannot include itself. So the only thing remains is max you get from I1 to 3 when sack capacity is 1. So for the current cell which I am solving for, current cell value I am solving for the m is 1, P3 plus 1 to 3. So max, this you cannot include because the weight of this item, I think it's not, it's P4. So the current item for which you are actually making a decision is for 4. And for all sub problem, you have already a solution for this. This solution is already computed. So you have to just build upon this one. Whatever we have solved on this, you have to build up your solution for 4 items. So it is I1 to 4. Max, this would be 1 to 4. This now solves to P4 plus this. This you will completely rule out because you cannot include this item. This weight is 5 and current capacity is 1. You cannot include this. So when you cannot include this, the only option remains is from I1 to 3 and this. So what is I1 to 3 and this? 3 items to solve and sack capacity is 1. 3 items to solve, sack capacity 1. I'll get 1 here. So tell me till what we have to move. Can you tell me what's the solution for this? Yeah. So there Gurunath has responded. So the answer will be 6. Answer will be 6. For this, now let me highlight this. I hope you are doing this calculation, or you can. What will be the solution for this? So can I include this? You cannot include. If you cannot include, it would be just max of this. See, weight is 5, weight is 3. Can you include? You cannot. So what will be the maximum from previous with the same capacity? Maximum from previous with the same capacity. So what value you will have? 10. Okay. Can you include this 5 element with weight 5 in this 4? You cannot. So maximum will be from the previous cell maximum with that capacity. So what you will have here? 11. Okay. Now the tricky part starts here. Okay. So here. So now let us do a calculation for this. You will understand that. Weight 5, the current the knapsack capacity is 5. Can you include this? Yes, you can include. So now let us do a calculation for this. Rest I expect answer from you. So what is sack capacity? 5. So now if I have a sack capacity of 5, then this will turn out to, how this will turn out? The P4, what's the maximum profit P4 I get? 16. And here what I have, then M minus W3. It's not W3, it's W4. I'm subtracting W4. So what is this? Max of 1, 2, 3. 5 minus W4 is 0. And this still remains. So this is what I'm solving for. 16 plus 16 plus something, and I have some value. So max, when I have 3 items to process, sack capacity 0. 3 items to process, sack capacity is 0. What is the answer? For that is 0. And what you have? Max 3 items to process, max profit when you have 3 items to sack capacity 5. 3 items to process, sack capacity is 5. What it is? 16. What's the max? 16. You can just write it here as 16. Okay, so it could be either these 2 items or this could be this one. Uh, for us, it is just same thing. So we'll just write it here as 16. So now for this, see, it's very important to make sure these 2 are well calculated. So I'll calculate for you if you can. Okay, now what it is? It becomes 6. So 16 and it becomes 1 and it becomes 6. This is what the call translates. So now for this case, 10 meters 16. So max profit, 3 items to process, sack capacity 1. 3 items to process, sack capacity is 1. What is the answer here? 1. So it is 16 plus 1, or max from 1 to 3, I 1 to 3, sack capacity is 16. Okay, so 3 items to process, 3 items to process here, 3 items to process, and sack capacity as 6. 3 items to process, sack capacity as 6. What it is? 17. So now if you take 17, what you get here? What is the maximum here? I think it's till 17. Am I right? I hope you understood this. So 1, 2, 4, 6. How much? I think what is M? 6 minus 5. It will be 1. Okay. Yeah. So for this, if I solve it for last cell, what will be last cell here? 7 minus 5, 2. And this will be 7. This will be 7. So 16 plus. Max I get 3 items to process, cell capacity 2. 3 items to process, cell capacity is 2. I get 6. Or if I exclude that, anyway I can include that, but there is also possibility what I'll get if I exclude this item. If I exclude this item, this is what happens. So 3 items to process, sac capacity as 7. What's the solution? 17. So what's the max of this? 16 plus 6, or what is 16 plus 6? 16 plus 6 is 22. So what solution I'll get here? 22. Okay. So can you tell me what cell location here indicates maximum profit I get when I consider all these elements and sac capacity as 7? What is that cell location? What is that cell location? Yeah, the last cell location, 4 and 7. So is it the max which I wanted? Yes. So I think if we recall our earlier solution, this is the maximum profit I received. So what is the maximum profit I'll get if I consider this profit? It's 22. Okay. Have you understood this approach? Is it clear? Have you understood how it works? See, now if you look at that, in case of recursion, it's see, both are same, exactly both this and this are same, but the way we are processing is different. Here we are moving from top to down. We are creating a problem, we are computing solutions, and when we were returning back from recursion tree, we are able to compute the solutions for that. That's a recursion. But slightly, if I reverse the approach, for example, instead of going from P1 and 2, if I change this order in this way, if I change this order in this way, what happens is you can build on your previously computed solutions. Okay, so if you look here, I know that for computing 2, I need something related to 0, 1. So I have already computed this. If I want something for 3, I know that I have to solve from 0, 1, 2 because there are combinations. So what I have done, I have already computed this. So your solution keeps on building from this, and it reaches to this. That's how your solution reaches. Okay, then you reach to a solution. So if you look here, the smallest problem is this, next smallest problem is this, next smallest problem is this, next smallest, next smallest, next smallest, so on. Here your solution keeps on building on the sub problems. This is a true dynamic programming approach wherein my solution starts building upon sub problems of smaller size. And the beauty of this approach is, for example, once you have done that, now what I'll do is I will delete this table. For example, for time being, I will remove this last item. Assume that I have removed that. Now I'm asking you, what is maximum profit I'll get if my items has 3 items and sac capacity is 7? Can you tell me, do you need to do once again all the calculation? No. If you have computed for I4, somewhere this table will also contain the maximum solution for this. Where what will be the solution? This. For example, this is a table. For example, if you have this table and if I ask sac capacity is say 5, do you need to compute again? Somewhere here this will give you the maximum solution. What is this maximum solution? 16. Its sac capacity is 5.
Recursive 0 1
That's how
knapsack.
you start working.
And if you recall this program, we started with recursive approach, and then we have applied memoization. So where did we apply memoization? This table. Okay. And then when we further scroll down, here is where we are actually applying that. So every time when we do that, we are checking if there is already a value in this. If there is no value, we'll go, we call it, and we store it. Next time similar call is made, we directly call that method. So what we'll do is we will comment out this approach. What I'll be needing is I'll be needing these items. I'll be needing the sac capacity and memoization table. From here onwards, we will come and decode. Okay. So once we are done, we will start with new approach. And let us do one thing. Let us take the method signature as it is. So you will see how easy it is to convert the recursive into tabulation method. So we obviously need a table to be defined. Let us do one instead of every time scrolling to the bottom of the page. Let me start with we were done here. Okay, let me write tabulation method start and okay. So I'll be expecting some help from you. So I want you to provide code snippets whenever I ask. So make sure you are in a position to type it. Okay. What I wanted. I'll use the same method, but here max profit. I'll say what I'll call. Okay, so I'll call that as max profit tabulation method. So I'll be still using the same parameters, items, capacity, and index. Uh, okay. So tell me what the first thing I need to do. So if you recall our earlier lecture, what was the first thing we have done in the tabulation method? What we need to do the first thing? See, in this lecture, I expect more interaction from you because I don't want to blindly write the program. I want to get the answers from you. So if I want to start with tabulation method, what's the first thing I need to figure out? The first thing I need to figure out is the table. So what would the table contain? What would be the dimension of the table? And what are the values of that? See, for zero and knapsack, it's a two-dimensional. For some problem, it could be one-dimensional. For a very complex problem, it could be even three-dimensional table as well. As of now, we are focusing on two-dimensional. So let us create that table. For recursive approach, we have already created that table. Okay, so what we'll call this table as? And table is the one which we frequently require for repeated iteration. So it is up to you whether you create it globally or whether you create it locally. So I would prefer it to create uh, and let me call it as dp underscore table. And most literature on internet, they always call it as dp table. So what are the table which we have seen? Some people also call it as dp table, dynamic programming table. So let me call it as, we will just call it as table. What was the dimension of that? So we have rows and then we have columns. So when we have a row, what would be size of row? Recall number of size of row. So in Python, whenever we define two-dimensional array, the inner one always the multiple of inner this whatever the size you define for in this inner row, where right now which are highlighted cursors blinking, that defines the number of columns. And whatever you give a multiple to the outer one, right now the square brackets are highlighted yellow colored. Whatever multiplier you give it for you, that becomes the number of rows. So in my case, what was the value I was talking about? I always want to initialize table always with the -1. Okay. Then how many number of columns I need? Recall from the table. If I have a C as if I have M, which is also C in my case, I refer M and C as both the same. So if I have M as a total capacity and items as the list which contains
the items, what's the size of table I defined in my approach? What was the size of table? The two-dimensional table. If I'm not wrong, items were 4, capacity is 7. So m plus 1 will become number of what m plus 1 columns, and if I have n items, n plus 1. So columns is equal to total capacity 1 1, yes, and rows is equal to number of items plus 1, yes, yeah. So internal rows multiplied by number of capacity, so it would be m plus 1, and outer thing is entirely multiplied by the entire length of items. So length of, in my case, it length of items plus 1. This creates the entire DP table. So initially, if I have 4 elements, then how much it would be? 4 plus 1, 5. So 0, 1, 2, 3, and 4. And m plus 1, the see here the index itself directly denotes the capacity and the size of elements. So why we see, you can even optimize it. For example, you can completely omit the 0 row and 0 row, but it is up to the developer how you want to optimize. There is always scope for optimizing minimum small space and small computations. So as of now, we'll stick to this one. Okay. After creating table, can I do what would the next approach? So I have created a table. I have initialized it with the -1. After that, I have to do something which is very trivial. I did not write a very complex code to design that. So what it is? Initialization of table. So in initialization of table, what I'll do, if you recall the table, some rows and some columns in that are the values are fixed. What are those? For example, first column. What does first column indicate? Number of items to process is 0. If number of items to process is 0, what will be all cell values of that entire row? 0. At the same time, first column. So what is the first column? So first column, if I have capacity as 0, what will be profit? 0 0 0. So I need to initialize the first row and first column by zeros. How do I do that now? So okay, do we need a loop? How do you do that? I think now if you see here, I think what we can do is, instead of initialize it to -1, what if we initialize it with 0? Do you think it will make any difference here? Let us just think, like, instead of writing to initialization, what if I initialize entire DP table with 0? I think the minimum profit will be always 0. And if I fail to calculate any cell value 0, I think it won't affect. So as per the logic and approach, I don't think initializing it with 0 will make any difference here, right? So if I initialize with the 0 here, I need not further write any loop. Okay. Do you agree with this? Do you agree with this? If I initialize with 0, I am initializing everything by 0 0 profit, and I'll directly start with 1. When I want to start my algorithm, I'll directly start with 1. Okay. Okay, so let me start with 0, and if something doesn't work, we'll come back and we'll rectify. We'll always debug the program. Okay. So initialization of table and creation of a table. Tell me what should I do? Now let us write a program for. Now you can write a code here. So how would you prefer to write code here? See, how do you iterate? Column wise, then row, or row wise and then column? What is in each iteration you keep on changing? So see, obviously we are here, we need two loops, outer loop and inner loop. So if I start row, internal loop will move column wise. If I make outer loop for column, internal loop will traverse me row wise. So how does my approach start there? So I start with one capacity and I keep on filling values for each capacity for that number of items I select. Recall that. If you recall my last lecture, I used to highlight a red cell. How was that red cell moving? Was it moving column wise? Then coming to next row column wise, then moving to next row column wise. So outer loop has to be row wise and inner loop should traverse me for column wise, so that for that specific set of inputs which is denoted by row index, I traverse from zero capacity to the max capacity to the last cell, right? So what should be the initial value for I in? Write some value here for j in. Okay, range. Okay, now I need to figure out what values I should write. For I will always start with 0. 0, it is already we are done. 0 means it is always 0. It is 0. We did not compute anything. It's already computed. So we will always start with one item. And range till max where it will go. So I want to include that as well. Till max where it will go. Length of, if I just say length of items, this will be excluded, right? I want to include that. Okay, so from 1 to length of items plus 1. What do you think? Is it plus 1 or 2? If I length was 4, 4 plus 1, 5. Did we create? I was at index 0, 1, 2, 3, and 4. So length of items should be included in that. So let us include that. And loop will start from 0 or 1. This will also start with 1 because I don't want to compute it for 0. Till where it will go to? Till it will go to the m plus 1. Okay. So from 1 to m, it will go from 1 to m. So this 1 plus 1, this plus 1 value will be ignored here. Let me do it. Okay. Okay. So now what should I do internally? See, whenever I was in recursion, I used to calculate two profit values. If you say profit included and profit excluded, I used to calculate both the values. Are we also calculating multiple profits here? So as a quick, let me take back to you to the, okay, so if you look here, I'm also calculating max. In recursive 2, I had to calculate max of this two. This was profit included, this was profit excluded. Here too, I have same approach, profit included and profit excluded. And what I do is I take a max of this two. That will be the value set for this specific value. So going on this, okay, can you tell me? So initially I'll start with this cell. I'll move to this cell. I keep on going to this. Then my code starts at this cell. It reaches to this end. Then it starts from here and it reaches to the end. And when we were solving that, it was very obvious to that for any value to calculate in this row, the values in this are always dependent on values which you computed in previous rows, right? So before I compute anything, I need to ensure the previous values are computed. And that's how my loop is also traversing. It is traversing row wise. So before I calculate anything for any row, I always first calculate values for its previous row. Okay. So moving back to, So do you understand that here too we have profit included and profit excluded? We have both. So we will almost keep our code similar to our recursion lines as well. So let me share back PyCharm again. Okay, so here too we will have the same profit included and profit excluded as well. So let me copy the code as it is here. Okay, two values, profit included and profit excluded. So when I have this both the values, how do you calculate profit included? Profit included, what it indicates? If I include that item, what it would be? It is always, it was something p plus some max, right? I used to write something this in that earlier screen shared. So what I do here, I need to add the profit. So it is nothing but profit plus next call to sub problem. It is minus weight. That's what I'm doing that, right? So here, instead of this, how do I get the profit of current item? The profit of current item, how do you take the profit of current item here? You will use this J index. This is the current item you take for that. Okay. So what is current item being processed? So how do you get the profit? Can you guess? Can you guess the line? What should I write here? Or shall I show the table screen? So I wanted some value here. I need to get the profit of current item. So as of now, considering this loop structure, what is current item here? Okay, so I is always same, right? When you have I here, I always indicates the current item. So from I, you move to the J, right? So what I do is, what is items of I, the first element items, and its profit. Where do I store profit? It's the second field, right? It's the first field. Item of 0. This is the profit associated with the current item plus what will the max. Either if you include this item, then you need to find out what was the profit which you could get minus the weight of the included item and the problem, reduced problem size. So this value, if you take here this value, where do you get the previous value? The previous value will be always inside the one row below it. So I can call it as upper row. The next value you are searching for here, it would be upper row to the current row. Look at the table. So I am computing for row is equal to 1. Then all the required values will be above that row in the row 0. So plus what you will write from table. So from table, what value you have to find out? From previous row means from table previous row minus at what capacity? Here I need to write a capacity. See, it is like previous row with some capacity. So if I include this item, what will happen to capacity? Capacity is reduced by the weight of this. Okay. So if capacity is reduced by weight of this, what I'll have? Previous row, if I am at I indicates current row, then previous row would be -1. What will be capacity? What will be the capacity now? So how do you calculate the capacity here now? So what is indicating capacity? Which row will indicate capacity? Here the capacity will be indicated by J, right? J is in the range of, this J indicates the traversal across your capacity. So here you will write J minus the weight of the current item. What is the weight of the current item? Items of I, and the second value indicates the weight. So this gives you profit of item included. Okay. Now we have to calculate profit of excluded. Okay, how do you calculate excluded? If you do not include this, then it would be table. It would be exactly same table, but previous row and capacity remains same. In the previous row, what was the maximum capacity when I excluded that element? So this includes the previous value. And once I have both these values, what should I do? Once I have both these values, I have calculated profit with inclusion, and I have also calculated profit without inclusion. So once you calculate, you need to calculate the maximum. What do I say? Maximum of this, and max of this will be profit for current combination of I and J. So you are calculating some value for specific cell. For that, you are specifically calculating values from what if item is included and what if item is excluded, and then you are storing that in the value for current row. So once you complete all this, then you are in a position to store a value for this capacity is equal to, what you write here, the max of profit if item included and max of if profit excluded. This is what you get here. Okay, I think that's it. So once you include in this table, that's it. And where would you get your solution? You will get your solution at the last value of your table. So before printing all this, okay, this is the method. We wrote our method somewhere differently. Okay. So now I need to print this. Let me do one thing. I'll print this value. In order to print the list properly, let me use something different. See, in Python, if you want to add new line, what you will do in for the print? I don't want in all that. I want to print row 1, row 2, row 3, row 4, and row 5, one after other in online, so that you can visualize that table. How do you print everything on a new line in a Python? What is the syntax for that? For each item in, okay, what I want for each row in a table. Where is my table? Where did I define that? Okay, so I am defining it in this. It is not required. It should not be in a function. It should be outside the function. So for each row in a table, I want to print it. Print row. But I want this to be printed on new line. You can always say end is equal to. Let me see what values you will get for this. So I think this is the same problem which we solved. M is equal to 7. Let us compare the values which you have computed. No, it's something different. Let me run, let me choose 01 knapsack. Okay, so okay. Before I print it, I need to call this method. Max profit items. What is the capacity? M. And I I don't think index makes any sense here. So I'll just write 0. So I have just used the recursive function method. Here index doesn't make any sense because we are directly taking. Let me do until let me eliminate this. We don't need this actually. Okay, let me run now. Okay, so let us debug this. What we are getting is the list index out of range. And where do I get? I get it at line number 16. I get it at line number 16. Index max profit and table of ij and items of ij. What is wrong here? Items of 0, table of table of. I minus 1 and j minus this. I think where it is exceeding the index out of range. Okay, so let us do one thing. Whenever it's such a case, the best thing is to always debug this. So I've inserted a breakpoint. I'll insert breakpoint at this location, and then now I'll debug that. So it is very important to learn debugging at the same time. Gurnath has he has put I should be I minus 1 or 1. Okay, we'll debug that. Okay, we'll debug and find out. Okay, so we are debugging this program. Okay, so initially I was stopped at that. So what was the first value of that? I, j, and 1. You can see I is equal to 1, j is equal to 1. See, when you put a breakpoint, the execution stops at that point. From then on, you can debug line by line by pressing F7. These are the items. 6 profit included. This both are the profit excluded is 0. If I exclude the item, yes. If I include the profit first item, obviously the profit is 6. Okay. I want to get the situation where we are exceeding that value. So now, next time when I include j is equal to 2, so I is equal to 1, j equal to 2. You can check the values. I is equal to 1, j is equal to 2. So I'm just pressing F7. Second item, profit included. What I'm getting profit included, still I'm getting the 0. Profit item excluded, I get 6. I think I keep on repeating it till I reach all the cells. Till j reaches to 7, I'll be repeating the same. Okay, j is equal to 3, j is equal to 4. Profit item included is equal to 12. I think something is missing here. We shouldn't get 12. Profit item is equal to 18. J is equal to 5. Something is not as per the approach we have discussed. J is equal to 7. Okay. So here I want to explore the value of table as well. So what is the value of table? This is the value of table. No. So this shouldn't be the value of table when I execute my first iteration. Something is wrong with the way we are initializing table. Okay, do you see here? This is the first row of table, second row, third row, fourth and fifth. It is computing values differently. These aren't the values. Uh, okay, so what we did wrong, can you guess? We missed checking some very important condition. Can you guess what it is? So we are every time we are considering that I can include the profit. But remember, when can I include the profit? There is some condition to include the element in that. What is that? The weight of current item being considered, it should be less than or equal to the capacity. Only then you should consider the profit of inclusion. If not, profit inclusion will be always zero. Are you getting what condition we have missed? The major condition, the important condition which we missed was I am always calculating this. Should we always calculate profit for including? No. Why? Because if of current item being calculated, if it is less than the current capacity being considered, is there any scope of including that object? No. So what wrong we were doing is we need to check if the weight of current element, where do you get weight of current element? This item of I, this second value, if it is less than or equal to the current capacity. What is current capacity we are denoting? J. If it is the case, only then calculate the profit for inclusion. If it is not, the profit has to be profit for that has to be zero, because you cannot include, the profit will be uh, zero, right? So I think now it should work. Let me pause this debug chain and re-debug it with. Okay, so now it is all zeros, zeros, and zeros. You see value for table, the table item zero. See, okay. Now the problem is this: when you keep on repeating this, this could sometimes lead to a reference issues. So let me take that. I think we have not yet seen that copy operations. If this is a case, I just want to be sure you are doing this for each I. Okay, this will make sure that I'm creating a new copy of array. Okay, it's been initialized to all -1, -1. Let me make it as 0 here directly. Okay, so now if I run this, okay, so 1, it included, so 1, okay, it included is equal to, okay, so now it's now you can see here it is working. Okay, so now you can see this, the tables are working. Okay, it is 1, 1, 1, 1. Then what is the next tables row? It should start with 1. The second should be 6. Okay, now do you see here the where I'm moving my mouse? Okay, 6, 7. Are that the records for that table? 6, 7, 7. Is it the right? 6, 7, 7. I think it should be. If I execute for next value 6, 10, 10, 11. Are we getting the values what we wanted there? So when I'm now executing for 4, 6, 10, I think I should end up at profit of. Okay, yeah. So if you check output, yeah, I think now we can see this value. Okay, instead of this, we'll run it. Okay, do you see this value? Does this table match with what we have calculated? Can you just confirm? Okay. So it does match, right? So that's the maximum profit we get. So where did we go wrong? I think let me explain you. You will now understand what exactly was the difference here. See, here what I did here, table is equal to, this is what I have done, right? The first value was 0. Uh, I wanted to initialize it with 0 multiplied by, what was that? M plus 1. This is what I have done. And here the entire, this whatever I created, I have multiplied it by length of this. Okay, this is what I have done there. Okay, now there is a difference between, let us call it as approach A and let us call it as approach B. There is a difference the way the tables are created. When I created that, I should get the it should have clicked to my mind when it was modifying all the columns. See here, this concept, it looks exactly same. It generates the same table structure. This generates the same dimensional table structure, same values. This generates the same, but the memory organization for this two is very different. Okay, it's a very good point. We'll discuss it in tomorrow's lecture. We will spend time on what was this difference between this approach A and B. Do you recall that once we saw about deep copy and shallow copy? Do you recall this? This is the culprit. I would say this is the culprit where we messed up. So when I went with this table structure, I was going for a table which did almost a shallow copy. So what exactly is the difference? We will see it tomorrow. That would be one lecture under Python 1. Then, so tomorrow we'll see the difference between these two, and we will look at more deeper concept of dynamic programming. As of now, this will work for any of your approach. Okay, so I think Akash was trying it on something. You can test it. See, I'll be uploading this code on GitHub and also the recording. Just check it with various approaches. If you find any test case where input and output doesn't match, let us know. We will debug these programs. Okay, so have you understood? Have you understood this? Okay, but I hope you understood. See, writing program was not a difficult thing. Algorithm, everything was far simple. We understood that. But converting into a table, that sometimes you need to take care, because now here we go into 0 index, 1 index. I think the first wrong thing was we missed this condition. Next was we somehow ignored this. We were able to identify during debugging, and this issue we identified when I was able to observe that when I was modifying table 0, it was unnecessarily modifying all table 1, 2, 3, 4 to on to n. So that should have given us a clue. Okay, and before I end it, do you know how many of you know difference between A and B? They are creating exactly same, but internally they are different. Do you know difference between this approach A and approach B here? How many of you know this difference? Do you know or not? If not, we'll look tomorrow itself. Okay, so I think I've done from this today's lecture, and let us see if you can explain me what is this in the Telegram group. We'll continue for tomorrow. Okay, so I'll end this lecture. Let us meet tomorrow and we'll discuss this further.